Welcome to the Istio Networking community meeting on this lovely Thursday. Today we have a full agenda. So we'll have a follow-up for Istio Pod Network Controller that was discussed, I think, about 2 meetings ago. We'll also talk about the Envoy Startup Readiness Health Checking, and there are 2 more proposals and discussions: secure egress traffic control in Istio, as well as self-service ingress to multiple Kubernetes clusters. So I think we'll do it in this order, and it would be great if we'll allocate about like 10 to 15 minutes for each topic, but no more. We'll try to stay within those limits. So Rafael and Andrew, are you online? For the first topic, the pod network controller. Okay.
Okay, we can move to the second one.
So yeah, we'll probably change the order. Let me see. Zach, are you there? Oh, Zach didn't join yet either.
I think Zach is on vacation.
He's on vacation. All right.
But I can summarize that issue if that is, if I let me double check the thing that he was asking. Oh okay. Yeah. So I think this was an old issue that, I mean, a PR and an old issue that we had, which was that by default, when we start, the issue is that, like, before, what you call pilot could actually send Envoys all the configuration, the health checks continue to fail because there is nothing in an Envoy that actually allows traffic to enter the pod or leave the pod. And one option that I actually had earlier was that when the system starts, like a default configuration that we can have for every Envoy is to allow all inbound traffic into the pod, so that all the health checks and other stuff will just continue to pass, and we don't have to play around with anything. And so this would, I mean, we would do it in such a way that we won't let any other outbound traffic other than only for the.
But that will prevent any other security. So MTLS will be completely gone. So it's not.
Yes,
really
so
viable.
it would. Yeah, so it would. Yeah, so that was
that doesn't work.
But this is only for people who are like okay with doing that. In other words, that because we still haven't found a proper solution for it, right? And so
we actually do have a solution that is. I mean, the problem used to be that Pilot was generating the config only after the endpoint was added to the service set, because Pilot couldn't know that a pod implemented service until it was added to the endpoints. And I think we fixed it before 1.0.0 was a fix. I see 100.
Yeah, exactly. So we consider
we look at endpoints that are not ready. So the problem should be gone. I mean, we should no longer have the problem that Pilot cannot generate a config before readiness is passed.
Well, I think there was somebody who actually commented on the 6 days ago, which said that, like, they keep getting connection refused from their Postgres containers. And
yeah, so it's not just readiness that's an issue here.
Yeah, it's
services will wake up, they'll try and make a network connection, and then fail and sort of crash or otherwise like not be built to retry their outgoing network connections.
I understand what you're saying. So I mean, we cannot have a solution that only works if you disable security. I mean, we want to be secure by default, and it will be completely weird to say, hey, if you want your service to work, you need to disable security. So we need a different solution for sure. But question is, what will be acceptable? If it's a problem is that the readiness check fails because you start the application and Envoy is not ready, then we need to consider how we can make sure the application doesn't start until Envoy is ready. I don't know if it is.
I think this was a short solution, a stopgap solution that I had, which was to simply let, by default, Envoy would just be a pass-through proxy until Pilot comes and overwrites all the configuration. But that's not, it's not a final solution by any means, because as you said, it's going to be like not secure by default, and it's just going to let everything through. But I think this was what Zach wanted to bring up in the in these 2 issues. This was a PR that I had a long time back, and So it's like a few months.
Let's look for alternative solutions first, and if we don't find anything else, I mean, one proposal. I mean, I mentioned it in the past. We have the init container. So the init container right now is doing almost nothing. It's just setting up IP tables, and it's running before the application. We could have the init container do a bit more and do a small request to pilot and download some initial configuration, and then when the application starts, Envoy will have a configuration.
Maybe.
No. I mean, otherwise it will not start. I mean, nothing will start.
I see.
So we can order this way.
But that means we have to share some storage between the init container and the other.
That's not completely unfeasible. I mean, we have a volume that is with the secrets. We have volumes that are shared. I mean, it's not really.
All containers in the pod share the file system.
Yeah, they share the file system. Well, not all, but they can share volume. The other benefit for this, there is another P0 that we have for 1.1, which Louis feels very strongly about, which is the dynamic setup of IP tables, where right now we remember we had that workaround for the security problem where IP tables is using the container ports, and people have complained that they need to declare container ports and so forth, instead of just us magically setting up the ports based on service. With this approach, with initializer making a call to pilot, it can download the list of inbound ports and the initial configuration at the same time. So 2 birds, 1 stone, or however it's called. It's not very hard to do. I mean, it's just basically pilot agent running in init container. We making a call to pilot, getting the config. We have secret. It may even wait for the secrets to be ready. So it's not, we don't have any startup problem because of secrets.
So it will build the bootstrap config as well.
We'll build bootstrap config. We may build an initial config with some preset configuration. I don't know.
That's an idea.
And if pilot crashes, it will still have a backup configuration.
Is there a design doc exploring the different options and their trade-offs?
Well, there's a bugs where different proposals have been proposed, and we discussed it several times, but we didn't get to a design doc per se. I mean, anyway, that's one alternative. I'm just throwing.
So by when you say dynamic setup of IP table, you mean that we get the list of ports from pilot, and we use that to set up the IP table.
Yes,
right?
And that solves the problem of container port. That's how the context where I initially proposed this, but. I don't know if it's practical. We can explore it. I mean, let's look for other alternatives maybe, but the fundamental problem is that if application starts before Envoy is ready, bad things happen. So the only solution I can see is to make sure Envoy is ready when application starts. Shriyam, what do you think?
Yeah, that's true. Yeah, I think the init container is certainly worth exploring. We can actually see how far we go. I mean, it should work for the normal cases, and maybe the Knative case might have some extra startup latency, but I guess they are anyway going to cache containers. So
does Kubernetes actually support ordering? Like, this should we talk to them about supporting ordering?
It supports ordering for the init containers. So those are run in exact sequential order, but not the other ones.
No.
Should we talk to them? What do you think?
We could talk with them, but 6 months from now, they will have a version that has.
They're not mutually exclusive. We would have to do both in parallel.
And it's not only, that's. Well, let's.
The semantics of a readiness check around that the pod is not part of the service till the readiness check is passing, and maybe that's what needs to be tracked for any other pods to connect to that specific pod through Envoy.
Right, but then you would need your app to change, or like at least your specification for the app to change to include a check on Envoy, right? So you would say your app is not ready until Envoy is ready. So then you need to add something to the app, and we want to preserve the application binary and also the YAML file unchanged, because that's one of the premises of Istio.
So at that point, I agree with. I was just wondering if for any other microservice to connect to this particular one, the readiness check passing should be a criteria for it to.
That's the case already. Yeah. So
actually, you know what? I think maybe the injector could add readiness in the app. like modify the application.
I know.
Right.
But what Spike has mentioned is that the problem is the application when it starts, it may try to connect to a service. I mean, the first thing you do when you start, let's say you connect to the database and pre-warm or do whatever. And if the connection to the database fails because you don't have outbound clusters, your application will crash. Will do exit, system exit, panic. I cannot connect to the database because the application when it starts, it expects to have networking. And until Envoy starts, you don't have networking.
But so if you insert a readiness check and your readiness check just checks for the Envoy.
No, but insert a readiness, the order is application starts
and then the readiness.
But application starts, panic, goodbye.
I see.
Yeah, so I mean, all hope is not lost because if your container actually exits, then Kubernetes will restart it.
Right.
But it's still kind of painful and annoying to have this thing where your containers in this restart loop until come up.
And like in theory, we want to see the number of restarts being kept to 0, right? Because that indicates a healthy application. Like if you see too many restarts there, it's something fishy.
I think with the restart happening, we are that's how we survive today because, it happens, but they restart and then they get to a stable state. It's not really a P0. People cannot use Istio.
Okay, so the other solution was like what Josh proposed to investigate with Kubernetes if we can introduce a
but we have to do it in parallel
dependency.
because we can't wait, as Costin said.
It has to be a wonderful feature. I mean, it's not necessarily bad, but it's...
That may be good in general, like in Kubernetes. It
they
seems
need
to
it.
be
It's not
very
just us.
useful.
I agree.
So if we can have
So I'll talk to them.
container dependency.
And I bet you there's already a bug open for it too.
And for the other option, I believe that it's already a P0 to have the IP table set up, fixed somehow.
Okay.
That's one of the options.
Yeah, I saw that in the.
Which other option? Like the second one?
No, the one I mentioned about having the init container be smarter, basically.
Oh. Okay.
Good, 15 minutes, perfect.
Yeah. So actually, we have one more minute. So does anybody want to add anything? Okay. If not, let me see. Vadim, are you online?
Yes.
Okay, great. So then we can go to the second topic, which is the secure egress traffic control in Istio. And if you would like to share your document, that would be great.
Yes.
Thanks.
Can you see my screen?
Yeah.
Okay, so I would like to present the requirements that we collected from several customers, the current solution and the current challenge that we have. So the requirements are, the setting is we have microservices that have to access external services, for example, some legacy databases or external web services, and we want to control this access, control and monitor. So the requirements that we collected, I think they are pretty simple, generic, straightforward, nothing fancy here. The requirements are the protocol to control is TLS with SNI. I guess this is the most popular protocol. All the traffic is encrypted to the external services. The second requirement is that it has to be transparent to the applications. So the applications have to continue sending requests to the external services without special configuration. And I think this is a killer feature of Istio, that you can do it. You can provide this transparent monitoring and control by injecting injecting sidecar proxies, sorry. The third requirement is to define policies and to enforce the policies. So there are two kinds of policies. The first one is per the whole mesh. So any microservice may access start.foo.com, a wildcarded domain, or a policy can be per specific host name, for example, mydb2.bar.com. Additional kind of policies is policies by source. So, for example, the user can specify microservice A may access start.foo.com and microservice B may access some specific host. These are two examples of policies. Additional requirement is to provide the monitoring of SNI, of all the access to external services. And the last requirement is to prevent tampering with the policies. Okay, so the assumption is that some of the application pods can be compromised, and despite that, the policy enforcement still have to function correctly. So even if we have some compromised pod, we have to prevent the attackers from escaping monitoring and from breaking policies. So any questions about the requirements?
Well, the last one, obviously, it's not something that we can support with Istio the way it is today. Maybe a requirement, but it doesn't mean that it's possible.
No, but he's talking about the requirement.
No, the requirement is good. I mean, it's not realistic, but it's a valid thing to wish for.
Okay, so my point is that today we can provide this in Istio, and let me show how.
Yes.
Okay.
Okay, so first of all, I guess we all agree with Kostin that sidecar proxies cannot be trusted. So there are multiple ways for an application to bypass its sidecar proxy. One of them to get root access in the container, not in the pod, not in the node, in the container only, and then run as a user with a user ID of Envoy, and then the traffic.
There are many others. Let's not. It's a long list of ways an application can bypass proxy. So let's not even.
Yeah, right. So here we work with the assumption that only the Istio components, the control plane, and the gateways can be trusted. And this assumption has to be made valid by Istio provider or cloud provider. They have to deploy Istio components and the gateways to dedicated nodes, the nodes that do not run any application, any application containers, the nodes that have some restricted access to deploy these components to dedicated namespaces and to apply some strict security measures for these components. So this is the assumption. So you can attack application pods, you cannot attack the Istio components. So it has to be provided by cloud providers outside of Istio.
I'm not entirely sure I agree with this assumption.
So sorry? So do you mean this assumption cannot be provided by cloud providers?
No, it's not necessary. I mean, I don't think it's necessary to have. Oh, sorry, go ahead.
Okay. And additional assumption is that once compromised, the attacker can avoid the sidecar proxy, as we said, avoid the sidecar proxy interception, and then the attacker can just, learn Istio, can read the code, and it can run its own fake Envoy proxy. It can get the certificates of the pod, and it can start sending fake mixer reports, and the attacker will try to break mixer policies. And our goal is still to provide secure egress control under assumption that some of the application pods are compromised. So let me describe how we can do it, in my opinion. Okay, so the first idea is to enforce control and provide monitoring in some trusted component, in this case, in the egress gateway. So we direct all the egress traffic through the egress gateway. Okay, so in Istio it is achieved by pilots sending routing tables to envoys. So we have sidecar envoys and we have the envoy in the egress gateway. And again, as I said, we have hardened security on the egress gateway. This is step one. Step two is this egress gateway component that we trust will send reports. Okay, we trust they will not be fake. We'll send reports to telemetry. We'll send check messages to policy, okay, to mixer, and their monitoring will be performed, and policy enforcement will be performed in the egress gateway. This is step three.
Sorry, can I ask a question at this point?
Yes, please.
How are you going to guarantee that the traffic?
Yeah, we're getting a nice
Egress.
Yeah, so this is step 3.
Okay, great.
Okay, so we have to prevent bypassing the gateway. For example, by defining network policies that all the egress traffic, let's say the only egress traffic that is allowed is the traffic that originates at the egress gateway. So no other traffic will be allowed. So we can use for that network policies. We can use firewall. We can, for example, prevent allocation of public IPs to the internal nodes, and we can configure native address translation devices. Okay, not to perform native address translation.
So sorry to interrupt. I see what you're trying to do. I think I understand it. What I don't understand is, why is this important for you?
Or for Istio?
Yeah.
I mean, I understand some customers may have these requirements and they can probably do it already with firewalls and other things. I mean, why should Istio add complexity and to support this use case? I mean, is it that important for all customers?
Yeah, if you could describe the use cases, that'd be great.
Yeah, so this is the use case actually. These are the requirements. So the use case is pretty simple. We want to control access to the external services, and we want to do it transparently.
But I could imagine just saying that the external services should be responsible for their own security. I mean, in other words, worry more about security within the mesh and entering the mesh, and not worry so much about leaving the mesh. That's somebody else's problem.
And also, I mean, again, everything is in a you have a route. I mean, if you want to prevent outbound traffic, you put a firewall rule. It's a resolved problem. You can say that nothing from inside the mesh is allowed to route outside by a simple firewall rule in the networking. And then
yes.
So, but I mean, I'm sure there's probably a valid use case behind this. I'm just asking you to explain it, or why is it important to you or your company or your,
Okay, so the idea is that once the attackers will be able to compromise some of the application pods, they may try to, for example, perform DDoS attacks from your cluster.
Yeah, yes. Sure, but DDoS attacks can be performed by people who don't use Istio. I mean, it's basically you're saying that, hey, Istio will not be able to do, but an attacker will not install Istio.
I mean, if you have a bunch of untrusted tenants within your service mesh, I mean, yes, this would be important.
So just not use Istio. It's easy for them to
but let's maybe see what's let's see the proposal till the end, and then.
But I mean, okay, that's.
Yeah. So I think like if I understand correctly, Vadim is proposing to always deploy the egress gateway.
Not always. I mean,
or like that's why I wanna hear exactly how we can prevent those like.
Okay, so first of all, let me introduce 2 more use cases. I mean, so I guess additional use case is that the attacker would try to just access, to steal data from the external services. Maybe the attacker will try to steal data from inside the mesh and pass the data to malicious sites, okay, to their sites, let's say, the stolen data. The malware of the attackers maybe will try to download updates for itself. So there are multiple, I guess, use cases, okay, that you want to prevent uncontrolled, unmonitored access from your cluster to the outside world. And the additional use case, additional good use case, sometimes you allow for user code to run in your cluster. And you also want control
that's the use case.
Your user code may access.
Do you have this use case, or are you anticipating this use case?
No, I have this use case, and actually,
you do.
Yes, and actually, I have a customer, and for them, this is a killer argument in favor of Istio. They want Istio for this egress control. Actually, they want to deploy Istio exactly for that.
But maybe we need better documentation to explain that Istio is not really solving this problem because it's not.
But this is a proposal for making
Yeah,
Istio
yeah.
solve this
So
problem.
yeah, let's
How-
see. Let's hear.
So far, I don't see any Istio here. I mean, I see some. I mean, your proposal is basically use IP firewalls, standard firewalls that exist and solve this problem. And there is no Istio required in Titan Mesh because the microservices will not need Istio for this to work.
Yeah,
And you are
actually,
saying-
yes.
Yeah, go ahead.
Yeah, sorry. So actually, the solution is to use the Egress gateway and to use telemetry and mixer policies. That's all.
That's already possible. I mean, if you put firewall rules, the Egress gateway is doing exactly that. I'm not sure what is different from what we can do today with the Egress gateway.
Yeah, it seems to me as well that this is really just saying here's a pattern of using Istio that you should follow and kind of documenting that and showing that. What exactly is the whole that needs a change in Istio, I guess, is what I'm not seeing here.
Okay, so good question. So let me present two challenges. Okay, one is solved and one we have to solve.
Okay.
Okay.
So this is the whole picture. We prevent, we blocking any access that is not through the Egress gateway, any Egress access. Okay. The first challenge is to handle wildcarded domains. So suppose we have a policy that allows access to start.foo.com and the request is sent to mongodb1.foo.com. So how can the gateway forward it? Because we have this limitation of Envoy, and Envoy can forward requests only to predefined hosts, and they are not known in the case of the wildcarded domain. Okay.
But the wildcard is in the policy, right?
Right.
Yeah.
You get the full domain in the SNI.
Right. So you get the you get the host name in the SNI, but Envoy cannot send. Cannot forward the request by SNI. This is a problem.
Why not? Oh, because it doesn't have it cannot use SNI for but that's exactly what Zero VPN is trying to address, basically, no?
Okay.
Maybe he's saying that there's no upstream cluster that is called MongoDB one.
Right.
Something?
Exactly.
And that's why it can't.
Yes, Envoy has to know all the let's say Envoy has to have all the clusters pre-configured.
Yes, this is another what we also call on-demand cluster creation.
So is this like a regional desk for SNI?
No. It's somewhere where Envoy doesn't know. It gets a route or a destination, and it doesn't have a cluster already. And then Envoy will ask Pilot, "Hey, please give me something for this." It's definitely one of the top requests for scalability and that way. I mean, it's clearly a good requirement for many other cases. So
okay, so here how we propose to solve it: to deploy additional SNI proxy on the local host on the in the pod of the gateway. So this is not proposal, for the standard Egress gateway. Since we have Egress deployment a la carte, any Istio provider can deploy their own Egress gateway, and in this case, the provider can deploy this SNI proxy. Any SNI proxy, we tried Nginx and it works. Okay,
Is it the same SNI all the way through, or is the SNI mutating?
So say it again, sorry.
Is it the same SNI all the way through every hop, or does the SNI change?
Right, it's the same SNI here.
So I'm confused here. I mean, I understood the previous part, but why do you need a sidecar for the application? I mean, I understand the Egress would need to take SNI and resolve it, but and then forward it, create a cluster for it. But why do you need a sidecar now?
The sidecar is for transparent routing of the traffic to the Egress gateway. But the application doesn't know that it sends a request through the Egress gateway. It just sends a request to the external service. And
but that's IP tables. I mean, that's the network policy. I mean, you are routing everything to Egress gateway through routing.
By the sidecar Envoy. By
yeah,
IP.
so network policy doesn't do routing. It just does kind of allow deny. Yeah, so you still need the Envoy in order to redirect the traffic from
route start to. I mean, you put the IP table, not IP table, IP route start through the gateway. I mean, it's standard. How many in the middle works, or you know how.
Oh, sure. I mean, you
HTTP
can do this in IP tables, but like you can do a lot of stuff that Envoy does for you in IP tables.
But,
like you can do load balancing in IP tables.
What concerns me more in this... Sorry, go on, Costin.
No, I was saying that the whole premise was that the application can be compromised, and if application is compromised, it will just not use the sidecar, or just bypass the sidecar. Or
Yeah, that's right.
Oh yeah, but the redirection is in the main line, right? Like for in when it's working correctly, you want the redirection.
Oh, I see.
And then you just shut everything down. If it's not redirected, then it just gets denied and never actually hits the network. But you still need it for when it's working correctly, behaving itself.
Again, let me stress the point. So since everything is blocked, every traffic.
I see what you're saying. Yeah.
Traffic is blocked.
I understand now. Okay, I get it.
Okay, has no other choice but to direct the traffic through the Egress gateway. The attacker has now somehow to cheat the Egress gateway. It has no other choice.
So if you don't have a sidecar or don't have some specific code to direct to gateway, you will be blocked. Like most enterprises require SOCs or some proxy to get out.
Right.
And you are saying that it could be provided by a sidecar instead of setting the SOCs proxy or whatever.
Exactly, bingo. So this is a transparent requirement. Okay. So now this is the challenge. The first challenge is wildcard domains. Here it is solved by additional proxy. Now we have additional challenge. We want to enable policies by source. Okay. So for that we have to use MTLS of Istio. Okay, to get the source principal. So now we have this MTLS tunnel. We have the original TLS with the original SNI, the inner SNI, and we have this outer SNI, okay, of the MTLS tunnel. And now the problem that we have that the envoy of the gateway sees the outer SNI of the tunnel. It doesn't see the SNI, inner SNI. So what happens is this envoy reports to the mixer the outer SNI, but the routing is performed by the inner SNI. So we have a security hole here, okay? So mixer receives the outer SNI while the traffic is sent according to the inner SNI. And we want to report to the mixer the actual host name the traffic will be sent to, okay? So we have now to extract the inner SNI, and this is the only part that is missing currently in Istio to support this use case. And we considered two solutions. First, to add what we call SNI reader filter to Envoy, and this SNI reader filter will extract the inner SNI and will send to the mixer the inner SNI.
So we cannot avoid the double encryption? Sounds.
Yeah. Yes. It'd be nice if you could avoid that.
Are you sure that's the only designs that can work?
Yes, because the strong identity, the identity of the source in Istio is provided by MTLS. So this is how you get the source principal.
But wait a minute. You are saying that you are going to do one MTLS to So let me rephrase. Can this be implemented in a way that doesn't add a lot of in a plugin or some ways that doesn't create a lot of complexity in Istio? Because I understand this is a wonderful use case, but we already have latency problems. We already have scalability problems. We have a lot of other issues that we need to resolve before we can take this kind of. Sounds very complicated to me. I don't know.
Yeah, but the whole issue is pretty simple. Okay. Just need this small filter to extract the inner SNI and to send
but you're double encrypting.
Yes, this is done in Istio today. Can be done today.
But what we're saying is we like to avoid the double encryption, and that's making it more complicated.
So what exactly do you gain by this? And so application. So let's say there is no sidecar Envoy for the application, because application could be aware that there is a egress gateway. SOCs, for example, or whatever, like they're doing today, and just makes a direct connection with an outer SNI. And I mean, could we, for example, just implement the SOCs protocol and which has authentication, or some of the other, you know, HTTP Connect, for example. HTTP Connect, you can authenticate the caller with tokens or whatever, and you can still proxy requests. What
Some
I'm
of these
saying
use
is,
cases don't have HTTP protocol, right? Databases,
Sorry?
other
Yeah.
like opaque TCP protocols.
no,
that
HTTP
aren't
Connect is opaque. The HTTP proxy, it's doing connect, and then it creates a plain
Right, but
TCP.
that's assuming the client's speaking HTTP in the first
No,
place.
but that's the Egress gateway, right? Envoy is speaking HTTP and it can receive any arbitrary traffic and then send it to anything else as plain TCP.
Yeah.
No,
Right,
what
but this
normally
origin-
happens is the application is initiating TLS.
So
Exactly.
application is
So-
initially.
This is what we're using in trying to do in Envoy for tunneling, where we're using the HTTP to connect extended connect in order to tunnel arbitrary traffic through Envoy, like, you know, whether it's MySQL, WebSockets, and so on between across Envoys. And the part of the proposal there that Costin is saying is that if you're using HTTP Connect, then we're effectively going to be talking from sidecar to Envoy over H2, which will where we carry all the metadata and all the headers and so on and so forth. With traffic comes in, Envoy unwraps it and then sends that binary payload to wherever it wants to go to.
So in other words, if the protocol that Egress Gateway implements is HTTP2 Connect, or there are several IETF proposals for proxying arbitrary TCP, UDP, all kind of other crap on top of H2. If we just implement the standard IETF proposal, drafts, we solve the same problem. I mean,
yeah, and we already
Without the double encryption.
halfway through doing that. Actually, Alyssa from the Boston team, she's already started doing that work, and we do have a rough way of doing that for WebSockets over H2, but there's still some more work that's required in NG HTTP2, after which we should be able to do tunnel arbitrary stuff over H2.
yeah.
So can we maybe have a review for this alternative design? Right, because we don't want to dismiss like a proposal without
Well, so I think that we're honoring the use case. Everyone thinks this is a problem to be solved. I think the only concern is just the double encryption. Is that right?
It's not necessarily that it's the complexity, and the fact that it's on original. It's something that nobody else is doing, and it's not clear how complex it will be, and how and interoperability. I mean, with the standard-based solutions, you may not.
Yes.
You may have applications that just use other protocols.
Right, and we also apparently we have another proposed solution for that. That's what Sriram was talking
That's
right? So so I
it's
think
the same thing, basically.
yeah, it's the same thing. All right.
And I'm not proposing it. It's there are other people on IETF proposing it. It's not my.
So I mean we're
Just
kind of
quoting.
running out of time here, and I want to give a chance to.
But one more comment. I mean, the first part definitely. I mean, I think it's super important requirement, and we should prioritize to get that part. I mean, on-demand cluster. I mean, it's the first part, and I think that we have no other choice but to implement this kind of on-demand clusters. Is the second part we may need to discuss a bit more.
Yeah. So there is also a document, right? There are the slides,
Yeah.
but there is also a document that Vadim sent. So I think it's probably fair to let people
Let's comment and discuss. Yeah.
go a bit through the document and enter comments, and we can have a follow-up on that. What do you think, Vadim?
Let me just summarize. So the only missing piece, everything is implemented actually. Everything can be done today with Istio, except for this small part of reporting the inner SNI. And we have these two solutions, and I would like you to read the solutions in the document and to provide your comments.
Yeah.
Okay.
What if the application is not doing SNI? What if the application is starting at TCP? I mean, just like we have this problem already of not getting visibility into the application if the application is starting already a MTLS connection or TLS connection. Assuming we solve that problem by direct integration or some other mechanism, if the sidecar would get clear text, would it avoid the double encryption?
I don't think so. So as far as I understand, in order to verify the identity of the source, you have to use the certificates of the source, the ones that are rotated by Citadel. Okay, so this is how you verify the source actually. So the source by its count.
That's one of the ways. I mean, there are other ways to verify.
Yeah, that's right. So the requirement is we identify the source, but we could potentially use a different mechanism that doesn't require double encryption.
Yeah.
Right.
Okay.
Yes. But the problem currently is more reporting of the Ingress and that's all. And we have to propose solutions.
May I ask a very short question, I hope? What is that TCP proxy then that's running? Is that another like container running in the...
No, TCP proxy is part of Envoy. It's a
I see.
plugin that
Okay, so it's not some other container.
No, it's Envoy TCP proxy.
No, this is actually Nginx, the SNI TCP proxy that they have. 8443 is Nginx.
Right, the right one.
Ah, okay. So basically that also require introducing another proxy in the gateway pod.
No, it doesn't require. I mean, that's probably just a Android. I mean, Envoy could do this.
Could do it. Okay. But we would need changes. So
that's
more
changes.
So one way we could do this is we could do some small piece of code just to get him unstuck and then do it the right way later. What do you want to do?
This piece of code is what we need for zero VPN. So it's and the other one is what we need for scalability. Okay. So those two pieces are definitely on many other lists.
All right. So I'll have to go to the next topic. I'm sorry, to interrupt abruptly. Thank you, Vadim. And let's follow up on this offline and maybe with another meeting. Okay?
And I think we can try to implement it, but...
Okay, let's follow up offline because I saw Gabe is here.
Okay.
And Angela, I'm not sure if Angela is here also, but they would like to discuss self-service ingress to multiple Kubernetes clusters.
Oh, okay.
Yeah. Hi, I'm here. I'll present.
Great.
Great. One sec. Sure. Great. So I'll just start with a brief overview of the use case we're looking at and sort of why we're presenting it in this meeting. So basically, we have a proposal for self-service TCP ingress routing to multiple Kubernetes clusters. So we're particularly interested in the use case of external TCP connections trying to reach an application on a Kubernetes cluster. When an application developer deploys their application, they want it to be able to be externally routable. We are also considering the use case of multiple clusters that are coming up. So while there is a way that on a per cluster basis, you can configure a load balancer and have your services externally routable, when you deploy many services on many different clusters, it becomes painful to manage external routability. So we're looking to solve self-service ingress routing for multiple Kubernetes clusters using building on top of Istio. So basically, we don't believe that this requires any changes to Istio as it exists today. But we wanted to see if this use case resonated with anybody, if they've seen anything similar, and had any general suggestions. So as you can see, no core changes. So we'll go down basically to the data plane design. So the idea is in order to have external routability, we wanted to deploy an additional routing cluster, is what we call it. And you would, as an operator, only have to configure a load balancer to forward to your routing cluster. And then, of course, you would expose a node port to forward to the Istio proxy. The Istio proxy would know where exactly the service is living and would be able to forward correctly to the node port that's associated with that service in Kubernetes.
Bit confused here. Is it the gateways that we have today? I mean, the different way to name the current gateway?
Yeah, so this would be the Ingress gateway.
Okay, so gateway, okay.
Yep. And so basically so all of this, the node port, the gateway config, and the correct forwarding would all be dynamically generated based on seeing a specific annotation on the node port.
Is node port required? Because many environments don't use node ports, they use load balancers.
Yeah, so we believe that we can also support the load balancer case. I think for just like an initial POC, we're looking at requiring a user to create a node port service. But you could believe like it could be extended to also be certain or be dynamically configured for services of load balancer as well.
Yeah, I would say the use case we're envisioning is on infrastructure that doesn't necessarily have automatic load balancer provisioning from the cloud provider.
So how does a node port work in this case? I mean, you get IP addresses for each node and you route them through DNS round robin, or how do you get internet traffic?
Yeah, so we're assuming that there is routability between the nodes, but not necessarily between the pods on the clusters.
And you have 1,000 nodes, you have 1,000 IP addresses, and you put them all in DNS?
We're not using DNS here.
How does traffic from the internet go? I mean, if I'm somewhere outside and I want to reach this pod.
Yeah, so the idea is you've configured your load balancer, or you've configured a DNS to forward to your load balancer for some, like let's say host name and port, right? And the load balancer will do port forwarding to your routing cluster. And based on that port,
So I think the routing clusters has IP reachability to all the other nodes in all the other clusters. So it's not the zero VPN.
And is the routing cluster doing like L3 or L4 or L7 routing? Do you actually need to look at like HTTP headers or anything like that to do that?
No, we're specifically looking at the use case of for TCP and not just HTTP.
What about using an L3 load balancer instead of the routing cluster? I mean, something like Catron or something like that.
All providers have load balancers, TCP load balancers, I suppose.
So that would require having a virtual IP for each backend service? Is that right?
Well, the load balancer may have one or multiple IP addresses. That's how they work. I mean, Kubernetes load balancer cluster, what I'm talking about.
So you're saying instead of
two different solutions.
Okay, let's talk about one at a time.
Yeah.
But probably it doesn't matter either. Let's go on with the design.
So I'm actually curious. So this does not require changes to Istio. That's what you said, right? So is it again from the category of best practices on how to do this kind of deployment and how to solve specific use cases?
I think they're looking for feedback in terms of where this model is right. And this is, I mean, a better way to visualize the context is if you imagine Cloud Foundry and Kubernetes. And this is one example where typical example is people in the Cloud Foundry, they would like to allocate a Kubernetes cluster just to run stateful services like MySQL or some of these state.
I guess the concern I have is that L7 load balancing or routing is always going to be more expensive than doing it at L3 or L4. So why pay the cost to do this at L7 here if you can get away?
They're not trying to do L7.
We're not doing L7.
I know, but the Istio proxy. But it's a gateway. The gateway. So the Istio proxy box is the thing that's
telemetry routing and all the other stuff that we are doing.
Okay, got it.
Yeah. So the use case is where they have the Kubernetes cluster, Cloud Foundry cluster, and they need some sort of...
That's pretty much what we discussed with Zero VPN and with all the other proposals for routing. I mean, it's very similar to what we discussed in the past.
So we haven't really gotten to the core part of this proposal yet.
Yeah, exactly. I saw the next diagram, so let's...
Sorry, node port is the problem with node port is that we run into a lot of problems with node port in general. So when you see node port, it's kind of some red flags are flying.
Yeah, no worries. So maybe we can just take a brief look at the changes that we're proposing to get that data plane into existence, or what we're building on top of Istio, because again, we don't believe any changes are necessary. So the basic idea is because you have multiple Kubernetes clusters running, each of your Kubernetes clusters needs to register with the cluster registry. We're proposing adding sort of a new extension, a new controller on top called the route manager that's watching the cluster registry and then can see all of the services being created on all of the clusters. And based on that, it is able to see if a user creates a service that wants to be externally routable, that we are creating an Istio config in the form of course, the gateway, virtual service, service entry, and then also we're creating a new CRD for external, for mapping external port state. So the idea is that each service that you want, each workload that you want to be externally routable will get its own unique port.
I have a question here. So is this the Kubernetes cluster registry we're talking about?
Yes, I think so.
Because I'm not sure the services are available there. So from what I
No,
know,
it's just
No,
getting
so
the cluster from there and
you
it's watching.
get information from the cluster, and then that gives you access to watch the Kube API server for each of the clusters.
Well,
okay,
you
that's
can
not
watch for
necessarily true.
annotated service.
So that's not true. First of all, the cluster register gives you the name of the cluster. It doesn't give you access to the clusters. I mean, that's the problem. I mean, multi-cluster, I don't know if you saw the designs that we have today and the implementation we have for multi-cluster in Istio today. The problem with cluster registry is that it gives you a list of registries and IP addresses, but you don't have any credentials to connect to the API servers and to watch them.
Like the secrets
The
or
secrets,
that
basically, the
kube
credentials.
config.
So what we do for and I don't want this proposal to kind of move us into a different direction from what we have today with multi-cluster, because again, people have enough trouble understanding the current multi-cluster.
Are you guys familiar with multi-cluster? Should we share that
apparently
information?
Apparently not.
Yeah, so we've looked at the multi-cluster. In fact, one of the things that came up the last time we talked about multi-cluster was that external ports needed to be allocated manually in order to proxy through arbitrary TCP traffic, right?
No. I have no problem with we're talking about two different things here. What Pilot is doing today, it's watching for some secrets, and whenever the secrets are created, the secrets contain a kube config, and they get those kube config and creates a connection to the remote API server.
Yes.
And then it's watching the remote API server for services, endpoints, and all other stuff. So this
But
part is already
how does it
implemented.
find that secret? Is that secret currently like manually created?
Yes, when the user adds instead of adding to cluster registry, the user is adding a secret to the main API server.
I see.
So
Okay, so is that something
you API servers you mean, right?
So,
Costing when you have multiple clusters.
Let's not get so let's say you have one cluster where you run Pilot. The cluster where Pilot is running, you have a list of clusters. Instead of putting them in cluster registry, you create this kube config and put it in secrets.
Okay, so you communicate directly with the Kube API server of the cluster that Pilot is running on.
That's what we are doing, and the problem again in your design is that you have no way for the route manager to connect to the Kube APIs to Kubernetes API because you don't have credentials. Cluster register doesn't store credentials, so in order for route manager to work,
we know that you would have to have a secret also generated in the
exactly. So the secret is required. Yes, and we plan to use cluster registry for multi-cluster. I mean, cluster registry will be added at some point. The only problem is that is not sufficient. I mean, one way or another, you will need to rely on the existing.
That's true. There would be another box here, right? Because the Kube APIs, like the Kubernetes APIs, to register with the cluster registry, we're envisioning the cluster registry would run on the same cluster as the route manager. So in addition to when it adds itself to the cluster registry, it could also be creating a secret, right?
If I can sneak another small fact here, what you describe here as route manager, which is watching the services, is already implemented in Pilot. So Pilot already is watching all the clusters for services and workloads. And
but it doesn't integrate with cluster registry. So I think the
it doesn't implement. I mean, it doesn't integrate with cluster registry because the cluster registry was insufficient. I mean,
right. So it has the same problem as the current multi-cluster solution with regards to getting kubeconfig credentials, right? But other than that, the design, the way it is, it's very good.
The design will match perfectly what we have if we use the same, if we don't re-implement and reinvent the wheels that we already invented. So besides these details, I mean, the second part, I mean, the part that I think is the core of this proposal, to have this creation of Istio configs and external ports, that's already something we are trying to do for the zero VPN, for the split EDS that we discussed last time. You remember that we discussed.
Right. So the thing there was that for arbitrary TCP services, port allocation on the outside had to be done manually by an operator, and that's what we're trying to address here with this external port CRD that we haven't had a moment to show you yet.
That sounds perfect. I mean, that's one of the missing, and it is something. I mean, we said that initially we'll create manually, but eventually we want to do exactly the same thing. So if you happen to do it, wonderful. I mean, it fits perfectly with the rest of the story.
We can scroll down and show that CRD now.
And I'm
So
curious
if they can get the integration with the cluster registry working, and maybe meanwhile we'll find some
Andra, forget about
solutions.
that's not relevant. It's a completely orthogonal discussion. Cluster registry. I think it's like not port is a red herring that is.
Yeah, I don't see that as totally integral here. I mean, if the cluster registry was key, also we could adopt it more unilaterally. But I think it's the CRD that we really care about.
The CRD. So the CRD is specific to Cloud Foundry?
No, it's not.
No?
So,
Okay.
like the use case that we're looking at is providing, like right now, and this proposal is providing external routing for Kubernetes clusters. So we can see in the external port CRD, the information we're storing is the port that is going to be allocated to be listened on the gateway, and then the host name that's mapped to on the virtual service to the service entry. And then we just want a unique cluster identifier as well.
But this will be something that needs to be implemented by Kubernetes itself. It's not something that is implemented by Istio. It's something that, each Kubernetes provider, I mean, JKE, AWS, and so forth, will need to implement. Why not modify the existing service? Because Istio is creating a service for the gateway with a list of ports that are forwarded. The Istio Ingress service, which is type load balancer, and internally has a list of ports, 8443, and a bunch of other ports. That resource can be edited programmatically by Pilot or whoever. And when you edit, any existing Kubernetes implementation will modify the load balancer because that's the specification.
So we have infrastructures where automatic load balancing provisioning isn't really possible. And furthermore, where provisioning a separate VIP or load balancer for each service is cost prohibitive. So what we're trying to achieve here is having a range of ports on a single external IP and individual ports.
No, I understand. Sorry, maybe I was confusing. So right now, Istio creates a single IP address, so it allocates a single IP address and a single load balancer. But the load balancer has a list of ports. What we are discussing here is editing or adding ports to the load balancer. So you have a service type load balancer, and inside you have a list of ports. And that works in most Kubernetes implementations that we know.
You're talking about like exposing the service on a list of ports instead of one port?
No.
They need a port range, not a list of ports. They want like something from 30,000 to 32,000, which you can't do within a Kubernetes service, right?
You cannot do it. Yeah, you cannot do a range, but you can do one by one. So you can programmatically add ports. I know that there's a bug in Kubernetes to add range, and I think it's been open for 2 or 3 years. Maybe you can upvote it. I don't mind. I mean, for some cloud, if a particular cloud provider has this facility to dynamically allocate ports, wonderful, you can generate this resource. But we need a solution that also works on, JKE, Bluemix, and all the other providers that don't have this external port facility. And I'm
not sure I understand this proposal is designed to be cloud agnostic.
Yeah.
Well, it's not cloud agnostic unless all clouds implement this proposal. I mean, you will need all Kubernetes provider to implement this external port specification.
Well, this would be a CRD, right, that you could apply to your
Kubernetes. But CRDs don't do anything. I mean, CRDs are just some strings.
Okay, so I think you're misunderstanding something. The route manager, it's the one that is creating and responding to these CRDs, right? This is simply a data store mechanism for the route manager to keep track of which external ports have already been allocated and which ones are still available for it to allocate. We're not expecting the cloud provider to do anything with this external port.
Oh, so you are saying that because you use node port, so we are getting back to node port. So you have the node port getting the traffic and use route manager in the node port to manage I understand now.
Yeah.
So your design is fundamentally relying on node port and is not working with load balancers. So it's not going to work if you have a service using load balancer, only if it's using node port.
It's assuming that there is connectivity from the routing cluster to the nodes of the user's cluster.
That's a bit different than the node port itself in Kubernetes. I think he wants to get to the actual node where the pods are running.
That's how you get to the pod by using node port.
I mean, you can get either way. Node port is more like about exposing that service on a particular node.
It's not. If you use a load balancer, a real load balancer in a provider, like you use cluster type load balancer. So in JKE, for example, this will probably not work. And I don't know about other providers. It may work on providers where the node ports are visible and allocated.
If you use a cluster type load balancer, in addition to that node port being opened, you get an external IP from a pool, right? And you basically get a firewall.
You get an IP address,
and that allows your traffic to get to that particular node again. So you get both a node port and an external IP.
Yeah, I wouldn't want to be hung up on like node port versus load balancer. I think that well, maybe we are just ending up, but I believe like the main thing is that the Istio, the Istio Ingress gateway, the proxy in the routing cluster is able to somehow communicate with the worker that the service is running on, right? So in this example, we're looking at the node port. If you had a load balancer, as long as, again, this routing cluster can forward to that, it should work.
So, right.
One small comment. Today, if you create a gateway resource with a particular port, the proxy, the gateway proxy, will automatically open the port. So you don't probably need the second resource because it's already implemented. So the moment if you use load balancer type node port, the moment you create the gateway, the proxy will listen on that port.
What do you mean load balancer type? Service type?
Service type node port instead of load balancer. So if you change in the current configuration, if you use node port, that's already happening today.
The gateway is already being configured?
Yeah, the gateway is automatically opening the port. So what exactly is the extra resource doing in this case?
Okay, I think in that case, if the gateway is already creating a service of type node port, then you wouldn't need to generate one. But again, I think that's a small detail.
That's one of the install options. It's one of the install options to create.
No, but I think we shifted away from the initial goal of routing across multi-clusters. So I'm not sure how you would know which node port is where.
Through the DNS stuff.
Yeah, exactly. So I think you still need the routing manager. And
so in this case, I guess the gateway is in the routing cluster, whereas the virtual services are in per user cluster. Is that a good way to think about this?
Yeah, I think that's probably a good way of summarizing it.
Yeah.
Thank you. I realize we're over time. Maybe if people
we're actually severely over time.
They can just leave some comments on it.
Yeah.
Okay, and if if you need to schedule a follow-up, please do so add to the agenda, and we can
maybe next week in the environments, because we multi-cluster and all this stuff. We tend to discuss it there as well.
Okay.
Well, thanks for your time.
Thank you very much, Angela and Gabe. And thanks to everybody for joining the meeting and participating. And sorry for staying over time again. Okay, bye. Have a nice day.